Assalamu alaikum wa rahmatullahi wa barakatuh. Today we are going to discuss another method known as Fibonacci method. This is one of the methods of one-dimensional minimization. So Fibonacci method. So it's based on the Fibonacci number, or in some cases you're going to also find as a Fibonacci sequence. So whatever it is, Fn is given the sequence. This is what is called Fibonacci sequence. So first two elements of the sequence F0 and F1 will be 1, and the rest of the sequence will be followed by this formula, that is Fn equal to Fn minus 1 plus Fn minus 2. Basically, the summation of the previous two. So the sequence Fn will be first two will be always 1 and 1. Then the third one will be summation of those two, that will be 1 plus 1, 2. The third one, summation of the previous two, so 1 plus 2 is 3. Then 3 plus 2 is 5. 5 plus 3 is 8. 8 plus 5 is 13. 13 plus 8 is 21. 21 plus 13 is 34. 34 plus 21 is 55. 55 plus 34 is 89, and goes on. So this series is known as Fibonacci series sequence or Fibonacci number. So what we are doing, the method of elimination, is basically we're trying to reduce the interval of uncertainty. So, and for that, so far we have seen that we choose two values. So whatever this interval given AB, out of that we try to find out two more values, say x1 and x2. And based on that, we figure out the function values at those 2 points, and whether it is a minimization problem or maximization problem. Based on that, we eliminate certain part of the interval and reduce the interval. So the method by which we are selecting this x1 and x2 is basically different in each method. So in the Fibonacci method, what we are going to do is whatever the initial value A and B given, we'll take an interval L2 star away from the A, the same amount of away from B as well. So basically, this will give you x1, say this will give you x2. So L2 star. Okay, so what we are going to get is x1 will be basically, x1 will be A plus L2 star, and x2 will be B minus L2 star. Now, what will be the formula for L2 star? L2 star will be Fn minus 2 by Fn. So these are Fibonacci number. So, and I0. Sorry, L0, the initial interval. So as you can, as you have already seen that, and so this will be L0 basically. So as you have seen previously as well, this number here is actually related to the number of the experiments that we're carrying. So that is why we, instead of going to L2, we're going to L1, we're going to L2, because of the fact that we're taking 2 at a time, 2 experiments at a time. And just for your, as a quick side note, only in the first case, we are going to take two experiments, and the other cases, in each cases, we'll be taking one experiments. Okay. So that is why you are going to see that we start with L2, then L3, L4, and goes on until we go to a certain defined value we have chosen to be fulfilled. Now, once we have these two value, again, the next procedure will be very simple. Find out the function at these 2 points, function value, and if it is a minimization, then one side would be off or discard. So this is how we have to proceed until the next value arrives. Now, what will be the value of L2? L2 value will be basically previous one, what was in the case, that is L0 minus L2 star. And also, we haven't talked about the exact value condition. So somehow if it is given 10% of within 10% of exact value. So in this case as well, similar formula that we have to try to use, and that will be ln by 2 by L0 has to be less or equal to given values of 10%. Now here, what will be the ln? So ln from the Fibonacci number, we can calculate. Basically, from the L2, we can calculate. So L2 is basically L0 minus L2 star, and L0 will be minus, and L2 star we already seen, and that is basically Fn minus 2 by Fn L0. So we can take the common of the L0. So we are going to get 1 minus Fn minus 2 by Fn. So what we are going to get is L0, then Fn minus Fn minus 2. So as we know that since Fn, next value will be the summation of the previous two, Fn minus 1 plus Fn minus 2. So if we subtract Fn minus 2 from Fn, then we are going to get actually Fn minus 1. So from here, we can see that our L2 will be basically Fn minus 1 by Fn into L0. So for nth case, since we have to carry the operation up to the nth operation, so similarly Ln will be Fn minus Fn minus 1 less. So basically n minus 1 by Fn also. So basically it will be F1 by Fn L0. So we know the value of F1 is 1. So basically it will be L0 by Fn. So we can say that Ln by L0 will be basically 1 by Fn. So from the exact value condition, we can easily write half of 1 by 2 of 1 by 2 into 1 by Fn will be less or equal to 10% or 0.1 or whatever the value given here. So this is the ultimate method. So now the same problem that we're solving for the last few cases, even though a more complicated problem we should be trying to solve, but to make things simple and to understand the procedure quite easily, we are going to use the same function. So the function same as before, that is f equal to x into x minus 1.5, and the initial limit L0 is basically the difference between b by minus a, or the limit was given as actually 0 and 1. So L0 was 1 minus 0 is 1. Okay, and also the in this condition given 10% within 10% of exact value. Okay, so the first thing that we should decide is what should be the value of n, and also we have to take advantage of the Fibonacci numbers. In some cases, you'll say the Fibonacci, the more correct pronunciation should be Fibonacci than Fibonacci, but in some cases you're from different region, they use different way to pronounce it. So Fibonacci number, we have to take the advantage of that. So Fibonacci number here is basically from n equal to 0, 1, 2, 3, 4, 5. Based on that, we can find out the values of Fn. Okay, so first two is always F0. F1 is always 1 and 1. Then we have 2. This is F2. This is 3, which is F3. 4 is basically 5. F4 is 5, and then you have 8 is F5. It can continue, but most probably we're not going to need more than this. So we know that the exact value criterion is given. So 1 by ln by 2 by L0 has to be less or equal to 0.1. So ln by L0 is 1 by f. So half into 1 by Fn has to be less or equal to 0.1. So you can see that we'll have the value here will be, if you just solve a bit, and then you're going to get that Fn 1 by Fn will be smaller than 0.2. So Fn will be, the sign will be reversed, 5, greater or equal to 5. So if you take Fn equal to, equal value can also be taken, the values of the function here. In that case, your n value will be 4. But to make it more interesting, I'll take, because higher value can also be taken. So I'm taking n to be 5. So your Fibonacci value F5 will be 8. So you are advised to check with these values, repeat the problem with these values. Okay, so this is your assignment, self-assignment. So now let's start with this one. The basic procedure is not that complicated, so we just have to repeat the iteration a couple of times to obtain the result. So first step is to find out the first iteration with iteration 0, 1, that is with initial value L0 is 1 minus 0, that is 1. So our L2 star will be 1. The condition is very simple. Is basically A, which is A is basically A plus L2 star. A is 0 plus L2 star. First of all, write the L2 star. Then actually you have to go to X1. So this is F n minus 2 by Fn into your initial interval of uncertainty. So now your L2 star will be simply n is 5. We have taken as 5. So F n minus 5 minus 2, that is F3 by F5 into L0 is 1. So F3 is 3. So 3 by 8 into 1. So 3 by 8 is basically the value is 0.375. So our x1 will be A plus L2 star, so 0.375, and x2 will be B minus L2 star, that is 1 minus 0.375, which will be 0.625. Now, next thing we have to do is finding the values of these two at 0.375 and 0.625. And also, it's always better to plot the curve. So what we have is this. A is 0, B is 1, and we have 2 points. At x1 is 0.375 and x2 is 0.625. Okay, so find the value of fx1. Fx1 will be, if you just put the value, that is 0.375 into 0.375 minus 1.5, then you're going to get minus 0.421875. Okay, for 21875. Okay, and value of fx2 will be, I'm just writing short. Please do the calculation to check whether there is any error in there or not. So 54885. Definitely, yeah, our fx1 is higher than fx2. So we discard a2 x1, which is equivalent to basically 0.375. So new interval will be x1 to b, that is 0.375 to 1. So, and also we can, it's always better to show the values here. Okay. So this is higher, this is lower. So once we have the new interval, then we can also find out the L2. which is L0 minus L2 star, and 1 minus 0.375, that will give us 0.625. So as you can see, in this case, we have two experiments. So this is 1, this is 2, x1 and x2. Now, once we are going to take the next iteration 2, we're going to say that one of these value, x1 or x2, will be retained, then other one will be introduced. So that is why in the next steps, we, instead of having two new experiments, rather we will have only one experiment. So that is why we'll say that the new interval, iteration 2, the new interval we already know is that 0.375 to 1. So our L3 star will be Fn minus 3 by Fn into L0. So Fn is, and n is 5, so F2. So F2 by F5 into 1. So F2 value is 2 and F8 value, F5 value is 8 into 1. So ultimately this will give us 0.25. So our value, now we are not sure which one will be introduced. So that is why we are not writing straight away number. So we write both as X. Then we see that A here is 0.375 plus the L3, that is 0.25. So this will give us 0.625. The point is already available. So it is not a new number, rather it is just the x2. So the other one has to be the new number x3. So 1 minus 0.25, which will give you 0.75. Now f of x2 we already calculated, and which is minus 0.54887. And f of x3, just plug in the values, 0.75 into 0.75 minus 1.5. This will give us the magnitude of minus 0.5625. Eventually, you know that this is the solution, this is the result, but yet let's go with the procedure. As you can see that fx2 is greater than fx3, so you have to discard the initial portion, though. So if you plot it, our starting portion was basically here, 0.375. In the middle, we have 0.625, which was x2, and the x3 is 0.75. Then we have our point B, which is 1. So this is new A. As you can see here, this one is larger than this one. So we have to again discard this portion. So our new interval will be, you can also show the discard portion. So discard 0.375 to 0.625. So new interval will be 0.625 to 1. Okay, so iteration 3. Iteration 3. So if we try to draw it, 0.625 then we have 1, and also in the middle we have point. We don't know yet which one will be x3 and which one will be x4. So let's find L4 first. L4 star will be your f n minus 4 by f n into L0. So f1 by f5 into 1. So f1 is 1, f0 is 8. So 1 by 8 will be the value. So basically 0.125. So your x, we don't know yet. So we are just writing both as x. So 0.625 plus 0.125 will give you 0.75. So this is previous value. So you can say this is x3. So the new one will be this one. So 1 minus 0.125. So this will be actually 0.875. So we have 0.75, 0.875. So this was your x3 and this is your x4. Next thing is function value at fx3. We already know minus 0.5625, and fx4 will be minus 0.5468 or 75. So definitely this is smaller, this is larger. So we can say that fx4 is greater than fx3. And because of that, we can discard this portion here. So our new interval is going to be 0.625 to 0.875. You can also write the discard portion. So discard 0.875 to 1. Okay, so iteration 4. So we haven't calculated in the previous case as well that the values of L4. So we can always calculate that. So L4 will be L3, okay, minus L4 star. Just do the same thing in the other case as well. So here, so L3 will be L2 minus L3 star. So it's not that important so far in the calculation, but we are going to see that eventually this method provides a range or interval if it doesn't give a more precise exact value. So we have to stop with a certain value. So the interval of the uncertainty we are going to obtain. So that is why it's always better to know these values. So next iteration, which is in between 0.625 and 0.875. And here our L5 star will be F0 by F5, which is into L0, which is 1. So 1 by 8. So again 0.125. So your x, we don't know which value it is going to come. So 0.625 plus 0.125 is 0.75, which is your x3, as well as 0.875 minus 0.125 is also 7.5. So basically we merge to a same point. So that has to be our optimum point, x opt. So if it is merging to a same point, then you can easily figure out what will be our optimum point. And if it is not, after a certain iteration, in that case, we have to choose the point that is in between. So, but in most cases, you're going to say that it is merging to a same point. So your f optimum will be basically f optimum will be minus 0.5625. So this is your method, Fibonacci method. So I will advise you to go with a few more examples related to this one to understand the procedure carefully. And one thing we haven't seen in this case, but probably in some difficult problems and complicated problems, you're going to see that the new point that is coming may not always be like what is have said so far, that it will be a plus certain L value, say Lj star, and b minus Lj star. So it may also happen that b minus Lj star can also come here, and a plus Lj will be going there. So not necessarily always this has to be x1 and x2. It can also reverse, like this one can be your x2 and this one can be x1. So this is one of the scenario that may appear in your case, but nothing to be worried about. Always remember that in the first iteration, you will have two experiments and the rest of them, you will always have one. So it will retain one of the previous value and one new experiment will be added with that one. Okay, see you in the next class, inshallah. Assalamu alaikum.